Okay, we could start. So today I picked out a bunch of problems related to like one and two variable stats. So a lot of like mean, standard deviation, that kind of stuff. So let's take a look at number one. I'll give you a minute to try that one. Okay, so here they give us the average um, must be at least 85%. And in the whole class, there's a total of 20 students. So with most like mean problems, I like to focus on the totals, meaning that if the average of the 20 students is going to be an 85, then the total points of all the students divided by 20 would have to give us 85. So simply just doing 85 times 20 is going to give us the total like amount of, I guess, percentage points that the class has to earn to achieve this goal. So that is 1,700 points. And then the first 15, they've received an average score of this. So that's 82 times 15 is the total number of like percentage points again that those 15 have earned. So 82 times 15 is 1230, right? So the difference of this is that how many points they still need to get to this 1700. Now this one's a little tricky. It says, what's the lowest possible score the 16th can receive? Well, it says nothing about the 17th, 18th, 19th, and 20th. So that's four students. So to make this person as low as possible, we have to assume that the other ones are going to be as high as possible. So that means that those other students must all earn 100. So that means that's a total of 400. So again, this is the 17th, 18th, 19th, and 20th students. This is assuming that they get 100. Now that brings our total to 1630. So this 16th person, they must get at least a 70. Because if they get a 70, we'll get to our total of 1,700. And the thing is, if any of these 17, 18, 19th, or 20th people get lower than 100, that'll just make this person have to get an even higher score. So the lowest score that they could possibly get is 70, because anything less than that would require these students to get higher than 100. And since it's out of a percentage and we're not assuming any extra credit, that would be impossible. So this person has to get a 70 at least to give them still a chance to get this pizza party. Okay. All right. Try number two. So again, more averages or means. So again, I want to get into the habit of every time we have like a mean problem, typically the way to get started is to find the totals. So right away, when I see that there's 23 positive integers and they have a mean score of 83, the first thing I'm going to do is just 23 times 83. And that gives me a total of 1909. So the total of, if I add up all the data points, I know it's going to be 1909. Then something happens, which we'll get back to. Now we have three data points were removed, and the average is an 87. So now I have 20 data points that have an average of 87. So that total is going to be 1740. All right. So basically, quickly I can figure out that what was removed is if I just subtract these, and that's 169. So that's not the answer, but so I shouldn't have circled it yet. But the idea is the total was 1909, the new total is 1740. The difference is what was removed. Okay.
All right,
So
got it.
I removed 169 like total points, but it wants the greatest possible range of the values. So I removed the highest and the two lowest values. Well, since the numbers just have to be positive, I'm going to assume the two lowest values were a 1 and a 1, and then question mark,
Okay.
because I want to make it the greatest possible range. So I want to make the two values that I removed the lowest possible. And I can't make them 0 or negative because they have to be positive. So
Okay.
that means this question mark would have to be 167
Okay.
because that would give me a total of 169. And then finally, the range is the largest minus the smallest. So that would be 166.
Okay.
So the greatest range that we could get is 166. Okay. All right. Now we got some kind of comparing with median and standard deviation. Okay. So first, the median. The median is the middle number, and I'm gonna show you kind of two different ways to look at this. Um, so they don't tell us how many. So there's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's 17 pieces of data. And if you want to find the median, again, I'm going to show you a shortcut for this, but it's worth going over. You divide by 2, and 17 divided by 2 is 8.5. And then you round that up and you get the ninth. So the ninth value is going to be the median. So then you just go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So 13 is the median. So the median of data set A is equal to B. So we know 1 is part of our answers. Now, there is a much quicker way to do that. I just wanted to go over that for dot plots or frequency distributions.
Okay.
You can do that to find the median, but there is a quicker way. If the data is symmetrical, which both of these are, meaning it's just the same on both sides, then the middle number 13 has got to be the median. So like we could get the median immediately, but I just wanted to go over this way in case the data is not symmetrical. So now
Okay.
standard deviation is the measure of spread. So standard deviation is the measure of spread. It's kind of how spread out the data is, or it's really on average, how far is each data point from the middle? So what we want to think about is just which one has more points that are further away from the middle. So look at the ends. This one has 2 points that are at kind of the extremes, but this one has 4. So the one that has more points that are further away is going to have a larger standard deviation. So either way, so data set B is going to have a larger standard deviation, but they didn't even want us to look at it that in depth. This one says that they're equal, and they're definitely not equal because, again, this one has basically this one has these two values where this one has them in this position. So the ones that are further away are going to contribute more towards the standard deviation. So the answer is just going to be 1 because the standard deviations are definitely not equal. All right, try this one. Okay, this one's actually pretty simple if we understand one concept. And if we don't, then it becomes much harder. So when we have anything consecutive, and that would be consecutive even, consecutive odd, here just consecutive, I don't know, consecutive multiples of 3, anything consecutive, the median will always equal the mean. So that's super important because if they want the average or the mean to be 28, and there's 5 of them, then I just know that it's the 28 is in the middle. So then I have like 27, 29, and then 26 and 30. So it has to be these for 28 to be in the middle. And then the greatest possible value of these is just 30. So they said consecutive, so we assume they're by ones. They could have said
Okay.
consecutive even, consecutive odd, but the bottom line, anything consecutive, the median and the mean are equal to each other. Okay, try another one with mean. We got the average of 4 positive numbers is 15. So again, the first thing I'm going to do is just do 4 times 15, which is 60. So that tells me the sum of those numbers is 60. So I'm just going to do x plus y plus z plus say w is 60. All right, so that's the all of the numbers, are going to add up to 60. When the smallest one is subtracted from the sum of the other three, so let's just say x is the smallest one. So y plus, z plus w minus x. So when the smallest is subtracted from the sum of the other three, the result is 48. What is the average of these three larger numbers? Well, I can simply just add all these together. So I'm going to get 2y plus 2z plus 2w is equal to 100 because the x's are going to cancel. And then if I divide everything by 2, y plus z plus w is equal to 50. And it wants the average of these numbers. So then I'm just going to divide by 3. And then you could just leave that as your answer. 50 over 3 would be the average of these three larger numbers. So we don't need to find them. We just need to know what they are when you add them up and divide by 3.
All right.
All right. And if you want to get a little bit, two different ways, I guess, to get a little bit fancy is instead of dividing by the 2 and then the 3, at this stage, I could have just divided everything by 6 because that would have simplified to dividing by 3 instead of doing 2 and then 3. But you don't have to do that. Or we could have just treated this all as kind of like one variable because it was just the sum of the other 3. But either way, this is kind of a visual way to see them as separate, but we are treating them as one thing. Okay, this is just finding what's called the interquartile range. So just worth going over like how to do that. Okay. So to find the interquartile range, so the interquartile range is what sometimes we call the IQR, is just Q3 minus Q1. So Q3 is the third quarter and Q1 is the first quarter. So what we're going to do is first, we're just going to find the median. And the way you find the median is normally I would do the cross out method, but I want to keep the numbers there for what I need later. So I'm going to do like check. So I just do like first and last, and you just keep doing that until one remains in the middle. And what ends up happening here is I have 2 that are in the middle. So I don't need the median for this, but I still think it's worth going over. So the median would be 16.5. It'd be the number that's in the middle of 15 and 18. You just add them up and divide by 2. So it would be 16.5. So what Q1 is it's the median of all the data that's before the median. So if I write it over here, 5, 7, 9, 12, 15. That's all the data that's before the median. And the median of that data, I will do the cross out here, is the 9. So 9 represents Q1. That's called the first quarter. It's the median of the first half of the data. Then I take all the data after the median. So that's 18, 20, 22, 24, 27. And I find the median of that. And the median of all the data after the median is Q3. So again, just a little cross out, and I'm left with 22. So 22 is what's called Q3 or the 75th percentile. And then the IQR is just subtracting them. And that gives me 13. So that's just how you find the quartiles if you need them. So it's just, if you know how to find median, you're just doing median of the first half and median of the second half. All right, I'll make this one a little bigger. Okay. This is one where we should be able to do it without making any calculations. So the thing is this. To find the mean of a frequency table could take a bit of time. So it's like we have 2 10s and 3 11s and so on. We'd have to multiply and add those and then divide by the total. So we don't want to have to do that. Basically, if you think about it like this, since the frequency distributions are the same, it's as if data set B comes from just adding 3 to all values from data set A, right? Because it's like all of these are 3 more than that. Well, if I add 3 to every single value in the data set, the mean is going to increase. It's going to increase by 3, but I don't even need to understand it that deeply. The mean is clearly going to be greater in data set B because all the values 1 for 1 are just bigger. All right. So the mean of data set B has to be bigger. So this one's wrong and this one's wrong. So B has to be greater than A without us doing any calculation. Then the way standard deviation works again is it's the measure of spread, which is like how far it is from the middle. But in general, even more general, it's just how spread out the data is. And if I add 3 to every value, all of them are going to move up together. So if you just imagine a bunch of people and they're spread apart of a certain amount, and they all move up together, like let's say they all move right the same amount, the distance between them doesn't change. So anytime you add or subtract the same number from every piece of data, the standard deviation will not change. So the mean is greater, but the standard deviation is going to be equal. So that's just kind of a concept to understand, is that
Okay.
when you add or subtract the same value to all the data, the mean will change, but the standard deviation will not. Okay, so again, we're looking at how data changes here. So the greatest gas mileage, if this one is removed, so let's look at the mean first. If you get rid of the highest value, the mean is going to have to go down, like the opposite of dropping your lowest test score, right? You drop your lowest test score, so the mean, your average goes up. Here, we're getting rid of the highest value, so the average should go down.
Okay.
Which of the following will decrease? So the mean definitely decreases. So C is out. Now I'm going to skip over the median because the median could or not, like it, what we actually are going to kind of have to figure that one out. So the standard deviation. Now, again, the standard deviation is how spread out the data is. If I get rid of this point, the data is going to be less spread out. It's going to be closer together. This thing is actually increasing the standard deviation because it's creating this huge gap. So the standard deviation is going to decrease as well when I get rid of this. So that gets rid of 1 only. So unfortunately, I still have to check for 2. So the way we check for 2 is, and again, if you can figure this out super quickly, then go for it. But I just want to like explain what's happening here. And this is more for when there's bigger values. If you want
Okay.
to find the middle when there's 15 of them, divide by 2, round up. So the 8th value is the middle number. So I just go 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 23. Whoops. Now, if I get rid of this, there's 14 values. So I want to go over this part. We didn't talk about this on the earlier problem. When you have an even number and you divide it, whoops, I looked ahead. Okay, 14 divided by 2 is 7. Then that means it's halfway between the 7th and the one above it. So when you find median of a bunch of numbers, if you divide by 2 and round up, then it's that value. There's a definitive middle value when there's an odd number of numbers. When there's an even number of numbers, divide and it's that number and the one above it. But when I go and I do 1, 2, 3, 4, 5, 6, 7, the 7th and 8th value are 23. So it's going to still be 23. So because there's so many 23s, the median does not change.
All right.
So it is B. But I did have to check it because there is a way in these problems for the median to change if you remove a data point. So we did have to check. And then how you checked, whether you wanted to cross them out or whatever, but this is just how I decided to do it. Okay. Okay. So again, we're really interested in totals here, but we've got to read it carefully. So the average of the first 6 cubs was 22 months old, but we're looking at a year after that. So they're going to age 12 months. So the average of these 6 cubs is now going to be 34 months old. So if I want to find the total of that would give me that average, I'm going to do 6 times 34. So 6 times 34, that's 204 total months for those 6 cubs. Now these cubs, 1, 2, 3, 4, 5, these cubs that were just born, they are all on this date going to be 12 months old. So their average age, right? They're each going to be 12 months old. So that's 5 times 12. So that's a total of 60 months. So now when I add all of them together, that's going to be 264 total months old. That's like their total age. And then there are 11 cubs. So I'm going to divide that by 11 because that's, again, how we find averages. So 264 divided by 11 is going to be 24. So the average age in months is going to be 24. So it's the total of these 6 cubs who are 34 months old each, and the total of these 5 cubs that are 12 months old on this date. Okay, just a few more. So try number 10. Okay, so this one I'm going to do by just setting up an equation. So again, like earlier, kind of setting you up for these types of problems. The mean of 7 numbers is x, which means the total of those numbers is just 7x. So just like earlier, if you multiply the number times the mean, the number of the amount times the mean, that gives you the total. So now we know that the total number in our list is 7x. Then we add this additional number to the list. So I'm just going to call that y. So now the total amount of our, if we add up all our data points, is 7x plus y. And the mean of that is 2x minus 1. Well, I had 7 numbers and I added another number. So that means I have 8 numbers. So if I divide this by 8, I'll get 2x minus 1. So that's our equation that we're working with. What's the value in terms of x of the number that was added? So I just got to get y by itself. So 7x plus y, multiply this other side by 8. So that's 16x minus 8, and then get y by itself. So subtract 7x, and that's just 9x minus 8. That's the answer. You could get this by choosing your own values, but I feel like if you could just set this up directly, it's not too bad to solve. Okay, all right, we're going to do just 2 more. So take a look at this one. Okay. This is more of a conceptual question. So what I'm going to do to go over this, and this one we should be able to answer pretty quickly, but I want to go over something first. So we have this idea of measures of center, and that's mean, median, and mode. And then we have measures of spread. That's range and standard deviation. And I guess we could put IQR in that as well, interquartile range. So what happens is anytime, so this data set actually doesn't really matter. What matters is the second data set, we subtract 24 from every piece of data. If you add or subtract, we talked about this earlier, the same number from all the data, then all of these, any measure of center is going to change by that amount. So these are all going to go down by 24. And anytime you subtract or add the same number from every data set, the spread is not going to change because they all change together. So how spread apart they are doesn't change. So the middle will go down by 24, but the spread won't change. So simply, if you subtract 24 from each data set, the median will change, but the range will not. Just think of the highest and lowest both go down by the same amount, so the actual range of values won't change. All right, so this is just, again, more in general how we can look at these. And if we're multiplying or dividing by a value, that doesn't apply. This applies to problems where you're adding or subtracting from every value. Okay, and we are going to do one more problem. So try this one. All right, so we're just going to find these. So median. If you add up the frequencies, you get 18. So I'm going to do 18 divided by 2 is 9. So that means it has to be between the ninth and 10th. Whoops. So again, you take the total, divide by 2, and the median, if it's an even number, is going to be between that number and the one above it. Well, if I just add these together, the first 4 are 24, the next 6 are 27. So 4 plus 6 is 10. So that means both the ninth and 10th values are going to be 27. So the median is going to be 27.
Okay.
Now, the mean, I would probably just put this all into a calculator. So what you're going to do is just, it's like we have 4 24s. So you're just going to multiply them together. So like 4 24s is 96. 27 times 6 is 162. 30 times 2 is 60. 33 times 4 is 132. And 36 times 2 is 72. Then you're going to add those together. So again, you could have just done this at Desmos or put them all in the calculator, but I'll do that real quick. That gives us a total of 527. And then we have to divide by the total amount, which we knew there was 18.
Okay.
Oh, no. I wrote 77, but this is 72. So that makes this 522. So then 522 divided by 18, that's 20. Okay, that makes more sense. So 29 is the mean.
All right.
So the mean is 2 greater than the median. All right, there's a way to use Desmos with a frequency table, but I feel like you can just probably throw it all in the calculator just as quick. Median we should be able to find really quickly, but mean of a frequency table, you gotta kind of do it this way.
Okay.
Okay, cool. All right, then we can make that the last problem. So again, look out for my email
All
if you
right.
want to submit problems for next week, and I'll just see you same time next week.